What's up? So I know you guys are dying to know what happened. Let me shut my door. Turns out I was not banned, so that's good. I think there was some sort of like temporary shutdown, so we're all fine. And I actually got AlphaFold set up on the supercomputer now. So there were some little things that I had to fix. Wait, how do I go to Stream Manager? There we go. Yeah, just some minor things. Mainly, let's see. So, um, this is data. Nothing really had to change here from the documents online. So this ran fine for the most part. It actually took a lot longer than I expected. I guess because they have to get all of these. What was it called? If you look at this is like the output file from the data stage. You have to get all of these MSA sequences and queries and stuff, and like this is like super long. So I think that's why it took so long initially. It took more than like an hour or something. But I believe, and I need to ask ChatGPT about this, like once you run the data stage, I think you don't have to run it again, and you can just modify this here. Then you just add modifications if you wanted to, or change the sequence here. Um, so I gotta ask, I want to ask ChatGPT that. Okay, let's say we ran the data stage to completion. Is it fine to just modify this file with, say, a bond connection and use the same MSA as input? It shouldn't be too different, right? Yeah, I think it's fine if we do this, but let me give it this for context though. There's no way I can like copy this over. I guess I'll just set that. Now, this is version 2 dialect, so I want to see if only specific versions allow for modifications there. Hello fold. So this is version 4. Mm. I think it's at the top they talk about versions. I think it converts it. Version 4 required. Hmm. What ends up happening here? version 2. But when you run inference, it looks like this, which is kind of cool. They color it. Let me see what it's talking. Let me see what ChatGPT says. Yes. You need to change any chain sequences. Safe to use data when no sequence edits, no mutations, same chain IDs. You're just adding a connection. Change any sequence, even a single residue, or add or remove a chain. Okay. All right. So what I want to do then, I also want to ask it about so this would be the input then, right here, right here. So what I want to do is connect. So I want to draw a bond between something. There we go. Bonded atom pairs. So this is like a separate field. Bonded atom pairs. Okay. So do they have an example here? Yeah. So it kind of looks like this. All right, so how would I do this? I think I could just go like that here to remove the TPO modification. And then maybe down here at the bottom. So maybe I have the bottom atom pair. Oh, okay. I see. Yeah, okay. All right, so I think A specifies the chain probably. Corresponds to the ID field for that entity. Okay. ID field for that entity. Yeah, I assume that's the chain. So this would be on chain, oh, okay, no, it's right here. So it'd be E. E and E. So we want to connect just like here. So this is 42. So we want to connect, we want to make two things basically. Oh, that's actually pretty interesting, this prediction. So we want cysteine 46, the SG. So I assume this would be 46 SG. We want to connect that to um, so this would be CB, I believe. Yeah, because it would be threonine in this case. So it would be 42 CB. Now I wish I could remove this because I have like an oxygen bonded to it. But so this would be ring A, and then ring B. I'm actually pretty excited to see how this goes. So ring B would be here. Where's the cysteine? Yeah. So it'd be cysteine 56 SG. Connected to E. Serine 52 CP again. Okay. So what I'm going to do is just copy all of this and ask ChatGPT if it's possible to remove atoms. I don't think it is. So maybe later we'd do like a custom residue. I wonder if it talks about that. But... All right, let's just send this and see what happens. So let me check and make sure. The inference is still pointing to that, so should be good. AlphaFold, it would be, yeah, just that. It took less than like 10 minutes to do last time, so hopefully that's the deal here. All right, in the meantime, we will copy that. Where's my combo? Here. Is it possible to remove atoms in a residue? Should go pretty soon. Right now I'm running a accelerated MD simulation with a homolog. So this specific homolog is pretty interesting because it doesn't have a zinc binding site, which is thought to be required for ring formation. But this homolog actually catalyzes the same ring topology on the peptide, but it doesn't have the residues that would coordinate the zinc. So it's a pretty curious case. So right now I'm just extracting a PDB from the most recent restart file. So we can look and see how it's going. It probably doesn't look much different from the last thing I looked at, but okay, so we can see here that mainly the peptide itself is coordinating the zinc. I suspect this aspartate will end up grabbing onto it. So maybe this would be like a like an alternative site or something. But here, this was a helix, so this is changing its secondary structure. So this would be ring D, C. I actually don't think there's a ring B in this one. Yeah, I don't think so. What? So, what would be cool is if we see like this cysteine come close to this residue right here. My hunch is that it'll form in the dehydratase active site, but it's yet to be seen. All right, so we have inference running. It's good that it's not complaining yet. So I wonder if it'll overwrite this stuff. I probably should have changed the seed name or something. Ooh. Okay. So there's an error there. Error PTM type. Interesting. So it might have something to do with like, no. Can't delete individual atoms. Yeah, I mean, I'll do that later, I guess, but so let me give it this. I tried to bond the SG to the CB. Oh, is it because it has too many atoms, maybe? No, I mean, I don't think that would, because it doesn't even take into consideration the hydrogens. First, let me do this. So I'm going to remove this. I can do that, right? Yeah. Yeah, it should be good. All right. And then I want to show model this. Could it be the version I am specifying? Yeah, because I mean, I thought it would automatically detect it. I thought that's what it said. Alpha server, from the one in particular, offers more flexibility and control in defining custom ligands. We provide a converter in run, which automatically detects the input JSON format denoted as dialect in the converter code. Converter denotes the AlphaFold server JSON as nav. And the converter will translate it to the format AlphaFold 3. Yeah, that's what it did. So this was the input here. Yeah, dialect AlphaFold server, and it converted it to AlphaFold 3. So you had a real specific parsing error, not a version issue. PTM type must be a dialect with keys. If any modifications like huh? I'm trying to set up AlphaFold, at least predict something specific. I already set it up, but I'm running into like some sort of error. Modifications. Oh, do I have to have a modifications thing? Or, right? Instead of a dict. Oh. So I gotta put null? Yeah. Some people in academia are very what's the word for it? Luddites about it. So okay, so I think I just need to delete this. That's what AI is telling me. So yeah, ChatGPT is really good at providing like uh, advice on like specifics to like code and stuff. But it's pretty bad at like organic chemistry, for example. I grade a lot of papers, and I could tell that students are using it. Um, I don't really care if they use it to write. Like if it helps them convey their idea better, then I think that's fine. But um, when they try to write it to get like the right answer from it, then I could like pretty much tell. Like it basically writes like a very drawn out, verbose explanation, and I don't really observe like the keywords in their stuff. So, and it uses a lot. ChatGPT uses a lot of M dashes, and like I'm not even confident enough to use an M dash myself, honestly. So I know most people don't know how to use it. Yeah, it writes in a very flowery way. That reminds me, I gotta send off my proposal today. I'll probably do that later. Yeah, I want to get back into it. It's just lately I've been super busy with this stuff. So, tonight I'm gonna go play tennis. So I don't know about tonight, but I want to do it. I just can't do it during the day, really. I want to get back into it. Oh, that's cool. Who won? So I think from here, so this is like another thing I want to do. Okay, we're running. Hold on. See if we get an error this time. Come on. Fuck. Yeah, it's still messed up. Underground rap type song. Version 2 is fine here. It's purely malformed. I still got the same error. Even though I deleted the modifications.json part. Oops. I promise to get the winner a drawn album cover. Ooh, that's cool. What's your favorite album cover art? I'm trying to think of mine. I don't know if I have one. What? You know what? It might be from the fact that like so maybe it's because of this. Oh. So I was supposed to delete it. No, wait. Okay, I think I know what's going on. And so we delete it here. And I think we gotta delete this one too. Let's just see what this does. I've never really thought of it. Yeah, I gotta look at like it's like a playlist or something. Magnolia Electric Co. The music's a bit experimental though. I'm gonna look it up on my phone. I think I've seen this actually. That looks hand drawn. The one that sticks out to me is Little Ugly Mane, the Mr. Thug Isolation. I like that album cover. Here, I'll show you. This. He has cool album art. I like that too. I like this one. It's kind of like deep fried meme looking, but that's kind of why I like it a little bit. This one's cool too. It's actually a good album. Oh, wait, there was another one. Let me see if I can find it. This will be a legendary pull. I don't even know if I have this. Maybe it'd be in samples or something. Um, oh, not this ain't it. Damn. Yeah, I don't know. It was one, it was like an, or maybe it wasn't even like an, oh wait, is this it? No. It was like an album cover where you like literally couldn't make like, you couldn't make like a single thing out. It looks like something like this. I swear, like I've seen it recently. I like this one too. This one's dope. I'm trying to find that other album. Or, Yeah, I don't know. I'm not gonna waste any more time on it. I'm trying to click the link. Here. I need another monitor.
Yeah.
How do I go to? No, I kind of like it. The music is so bad too. Why is it playing? I don't want to get copyright stricken. That's funny. Um, where? This is the only link I got. Okay, I think we're actually running now. Yeah. You can't hear them unless you watch niche Guitar Hero videos with 200 views. What do you mean? Are you making the bond? Doesn't look like it. Maybe sample one. You won't find the music on any other platform, even the one I sent you. You really have to search. Oh, okay. So this is supposed to be close to this. We're gonna time out. No, I got it. Mm, why didn't it make bonds? Oh, it did. No, wait, what? That was weird. There's supposed to be a bond, but why is it doing that? That's so strange. Why is it making these crosslinks? Alright, let's send ChatGPT this. The code ran, but the predictions do not show a bond being made between cis and no. Maybe I'm doing something wrong. E. That should be right. I don't know. Let me download this. Let me look at that in Pymol. So, just for background, we want to make something like this. See this like S bond, this yellow thing? That's what we want to make with AlphaFold. And with the predictions that we just made, that's what it should look like. So this is supposed to be connected to that. Got this here. This to that. But it's not. Or no, sorry, it'd be. What would it be? Let's see. What's this? Searing. Yeah, it'd be that to there. But it's not doing it. And then there's another one that's supposed to be made. This one to that one. But it's not working either. Polymer bonds, protein ligand bonds, ligand bonds. Fold without, after prediction, create that ether and Pymol. What? Okay, so I think what I need to do is go pee first. But So we need to have a custom ligand, I think. So how would I do that? Um, how would I do that? I think I actually have some examples here, actually. It would be in here. Um, what is this crap? ABE. CFBCD octamer. Oh. Alright, not that. Okay. So this is how I have to do it then. So, um, thank you for letting me know that, Republican Beaver. So the ligand we have to define basically is DHA or ZDB. Extract. I forgot the order here though. Ring B uncapped, mol2, rib.cif. Okay. Atomic weight. So this creates the MMCIF. What does this do? I think this is the one we need. A input.py is the last thing I did. Convert MMCF to JSON line. So I use this, and then I use that. So this is probably the thing I need to do. Here. So I need to create DHA residue. Or let's try ZDP first. Where do I find that? Probably here. ZDB. Yeah, this will work. Just like that. Path to output, so this would be ZDB. We'll call it like 5, I guess. If this works, this will be clutch. Python mol2. I think it's probably Amber would be fine. Okay. zdb.cif, no structure available. But I think this would be the right thing. And then from here, you do so this will convert this lig5 if input lig5.txt, right? So then this can be so we can look at an example here. So we'll do user ccd we want lig5. We actually don't get that, do we? Does it need to be in quotes? Okay. So then we can bind. So we figure out the atom names now, which I think would be consistent with here. Okay, so I know we need to do this. So this is going to be ZDB. We need to erase that one here. 42. So how do I figure out what the atom names are? Lig1 and 5. So lig1 is probably the ring A. That's my guess. So let's look at the mol2 here. So they're uncapped. The atom numbers aren't here. Right here. Can't even look at that. Can't even look at that. So how do I figure that out? Can I look at this? Nope. Maybe I look at it in timemol. Yeah, I can. But it still doesn't show that. Oh wait, yeah, it does. N5, oh. Is that what's in the input here? Yeah, N5. There we go. All right. So I guess I need to add this as well under sequences. So I guess it'd be this. protein, ligand, 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 protein. Or I guess it'd be there, right? Maybe here. I don't know. If I put it here, I'll do it. And then I need a comma, right? And it needs to be leg 5. All right. So what do they have? 41C. It's going to be bonded to leg 1 and 5. Yeah, it seems legit, but I don't know if ours is N5 or not. So let's look at cdb.cif. So ours is N2. Okay, so I'm going to copy that. So not A, it's going to be E. E41, that makes sense. C, lig 5, 1, yeah, N2. All right, and then I need to find the next residue. So where do they have that? Here. Wait, lost. Okay. So they do A42N. I think it'd be the opposite direction now. So it'd be the C atom bonds to the N of 42. Or wouldn't it be 43? I mean, I think this has worked in the past, so so be that E, or wait, no, be lig 5? No, this is right. I kind of want to change the order though here, because I think that matters. So leg 5, I need to figure out what atom. So it'd be the carbon here, C1. Would bond to E42N. So would this be 40, like if I deleted this, this would become 42. So I think that's right. Okay, and then 42, so where are we at? 42, 43, 42, 43, 44, 45. So it'd be E45 SG bonds to lig 5 1, and this would be C21. Feels a little high. Yeah, why is it C25? Or C21. I guess that's just what it's called. I don't know. And that should be the first ring. So let's see if this works. So what we're doing is bonding the ligand, which is dehydrated residue, to atom 41, or residue 41 at the C is going to bond to the N, which the ligand C is going to bond to the next residue, and then the SG of the cysteine downfield is going to bond to the C21, the ligand. And so hopefully this will work. But let me tell ChatGPT what I did. In the meantime, we can go to output AlphaFold. Just remove that. Okay, so what I did was create a ligand for dehydrated residue and put it in the sequence with the CYS bonding to it. So we'll see how this goes. I want to know what the documentation says about making custom ligands. Here. Version, sequences, RNA. So you could use CCD codes. I wonder if dihydrobutyrene CCD code. DBU. Oh. Okay. The only problem is it has these So not quite. That's not right. Oh yeah, it is. I mean, could I use this? No, because like the oxygen there. I knew it. IDs must be uppercase. Got what? Uppercase letters. Okay. Um. So I'll just name it F. Just change this to F. I wonder if ChatGPT will catch that. What? All right, let's just see what happens. All right, so what is this saying? You bonded your linker to the backbone polymer atoms. So this is wrong apparently. The stress to insert the ligand into the peptide bond. A fold structure cleaner is conservative about polymer geometry and will tend to delete or ignore edits that over-constrain the backbone. You actually don't need to touch the backbone at all. Keep the normal peptide bond. Make one protein ligand bond from the CYS-SG to the ligand anchor. Make one protein ligand bond to the dehydrated residue side chain and the other anchor. Ligand 5, 1A1. I don't get it. Replace the residue numbers to match your system. Key point, SG to A1, CB to A2. Do not bond backbone NC. But why not? This doesn't make sense to me. Your user CCD is not a valid CCD syntax. Level 3 expects CCD style MMCI out. C2H2S1 link stub. What's a link stub? Cross your fingers. I don't really get what it's saying here. C2H2S1. A2. So if the stub is just let me see if this works first. Damn it. All right, so let me see what it's talking about here. Wouldn't it just bond to the dummy atom though? What does this error mean? I've used this code in the past and it's worked. Like with this here. It's a deck mapping parcel. Fix one, pass a string. Okay. Oops. So just do this. Yeah. L5. Okay. Just little things like that. Alright, let me go to the bathroom. You guys can just look at this. Alright, did it work? Dang it. Hasn't ran yet. We can check on the simulation. Yeah. Harm, hell, Saturn, Prime 7. Trash out test. Get rid of the water. What we got here? Interesting. So what's the zinc doing? Come on. That's kind of in the same spot, honestly. This is cool though. There's always a secondary structure that forms, like right here. It's like the alpha beta sheet, maybe? I don't know. Ooh, this is interesting. So this swung down. What's cysteine up here doing? Looks like it may swing down as well. So if this were to happen down here, what would be the asparagine has like pH of 10. We have arginine, which has, I don't know what arginine has. I think it's like pKa of arginine. 12? Okay. That's pretty basic. We have a lysine here. That should be 10, right? Yeah, 10. We're learning. This is an acid, aspartic acid. So aspartic acid has, I think it's 2, and then glutamic acid would be 3. But I see a bunch of residues that could potentially be catalytically competent. There's a lot of acid-base residues around. Damn, why is it taking so long now? It's edging me. So they talk about, so it's user provided CCD, right? Okay, from 2022. Hmm. Do they talk about is this it? Ligands. That's what I need to look at. Chemical component dictionary that describes all residues and small molecule components found in PDB. So what specifically is it talking about? Where are we? Let's check out of it. What? Oh, I probably just clicked the link. Um, okay, so providing a file path might be easier instead of creating an inline text. She might do that. The file must be in CCD MMCIF format. CCD MMCIF. Okay. So it'd be nice if they had like or dehydroalanine PDB. Damn. Ooh, this would be it. No. What it? I mean, I would need to change. Can you even download? They just have a CIF definition. Does this look like MMCIF? To me, it does. Kim underscore. So where's the Kim underscore comp? Play? Execute query? What the hell? This could work if it didn't have this methyl here and it didn't have that OH there. And if it was like an MMCIF file. I mean, maybe this will work, but I mean, this looks like what we have. Yeah. I mean, that's everything for this. The loop, yeah. So that should theoretically work. Bro, come on and run. So that's another thing we could try, I guess, but so then there'd be dihydroalanine and dihydro what would be the other one? Butyrene? I think it'd just be DBU, PDB. So here it's just the alcohol that ruins it. The N is okay. Actually, I wonder if we could do this. Where's that info at? Here. We'll go here. So this should have information on the residues here. DBU, DHA. There we go. So those are the two. Oh, that's cool. They actually give you the names and stuff too. Like, why do they have an alcohol there? Pro, please run. So let me just copy this and give it a ChatGPT. So I actually found a PDB entry for DHA. We could, I guess, use the CCD code here, but there is there's an OH bonded to where the carbonyl is. Here is the CIF. Is this at all useful for what we want to do? I mean, can we just put the DBU in the sequence? Because here it has that. What is DBB? And the DAL. There's DBU. DBU. Maybe this defines the stereochemistry actually. What is DBU? But not for making it direct CSDHA polymer bond. Doesn't allow polymer covalent bonds via bonded. That's well, that's cool at least. Bridge ligand trick, polymer ligand polymer. Keep your protein sequences normal. Introduce a tiny custom ligand that represents the thioether link. 2 to 3 atoms, 1 S anchor, and 1 CB anchor. The two ends must attach to a ligand, not each other. But the custom, what does he call it? The custom bridge ligand trick would bond the S atom to another S atom now. The ligand is only a placeholder that encodes the connectivity. I still don't really get how that would work. Ooh, are we running? Please no error. Come on. Please. I think that's fine. So far so good? Question mark? Dang it. First MSA sequence is not the query sequence. Okay. Alright, so I know I gotta do there. But I think honestly the custom ligand worked. So we need to delete that, delete that. Hopefully that won't mess things up. If so, that's gonna be annoying. So I have to do the data thing again. So this should all be fine. Please just run immediately. You can design the bridge ligand however you want. It just acts as a stub or scaffold that connects two different chemical groups through virtual atoms. Let's unpack that. The ligand is only a placeholder that encodes the connectivity of the thioether for lithium bridge. The real chemistry is how to encode this in AlphaFold. You can make the ligand look like a short group with a sulfur atom. CH2H4S1. Then you tell AlphaFold SG cysteine sulfur bonds to sulfur ligand sulfur. But the you're thinking exactly like a chemist here. What? Yeah, no shit. But then there'd be like an extra C atom out of nowhere. What's it? Okay, it's tripping now. this failed. Okay, well, that was so annoying. All right, let's just do this. We'll add back the T here, just so things work, and let's just see if we can bond the stuff together. Oh, come on, write the damn thing. Wouldn't it just be better to insert a custom residue inside the peptide sequence and then bond the two? Polymer ligand. It's still not understanding what I'm saying. There's no polymer bonds I'm making right now. Bro, how long does this take? else can I move on to? So we want to simulate, keep that open. So I have it pulled up. I need to get rid of all these tabs anyway. I want to keep that open. Yeah, be this. So we want to simulate this. This is an NMR structure. So what we can do is fetch this here. Okay. So probably what we need to do first is predict the peptide sequence of just this, which I have actually. We should probably just create a folder as well. So back out of that, we'll do, so it's LCH A or M A2, LCH A2, which I've done predictions for right here. Wait, can you open up folders like this? No, I don't think so. So there's this one prediction that I was super interested in. Maybe it's the SCP predictions. Yeah, there we go. Look at this right here. This sheet that formed. I'm actually pretty interested in simulating this. So maybe we could set that up too, actually. So I wonder if this has any, if this is realistic in any way. All right. Come on, give me the error. I can take it. So if error comes, be right here. Hmm. Invalid literal for integer with base 10. What does that come from? So that comes from the CIF file. Here's what I'm thinking. I think we look up the DBU thing. And just remove the alcohol here. So we would need to modify this, or we just literally bond it together. I don't know. Could do that. I guess we could try that. That'd be like probably the simplest way to do it initially. Just see if the CIF file works in the first place. So we'll go to input, touch, dbu.mmcif. Can't even view this here. Alright, so we can provide a file path to here. Um, um, it's only a subset. The mandatory fields. But they're necessary. Okay. Do we have all of these? That's a lot. I'm sure we do. Yeah, I think we do. I want an example of like the file path. There we go. So instead of this, so I guess my code doesn't work. It'd be that. I'll put it right here. And the file path is, do we have another example? I'm just going to put like the absolute file path. Hopefully this will work. That. Okay, so if we have the DBU, then this needs to be DBU. and 41C can bind to F, so that would be, where's that thing? Just be N. And FC1 would bind to, no, FC. E42N. Then E bond to here. CB. Pretty sure that's how that would work. Now we wait an hour for it to save. It just takes a while because of how big these lines are here. What was I doing otherwise? Do I need this? I don't think so. Oh yeah, I was looking at this. So let's simulate. Why are we simulating the peptide? I forgot the point of that. Oh yeah, to match to the NMR data. So how did I do that? Wait, let me check this again. All right. I mean, I guess I could just start it from here. Like looking at this. Or I could just use this and just rename these atoms. That might be a better strategy. Would that be a better strategy? Yeah, I think so. Yeah, we could do that, I think. So let's close this. And yeah, this is where we want to be. Touch. Damn, I forgot the name. Shouldn't have closed it. We can close this, I believe. What is this for? Put to trash. Here is where we need to be. So the name is LCHM2. Yeah. Or LCHA2. LCA2. And then I'll put the date 11/13/95. Oops. I'm supposed to make a new directory. There we go. All right, so we can open this, put in the starter files. Go to here. All right. So from there, I'm going to take this. So I guess we'll save this. Now I'm interested in what that is. 2KT. I think that's just a capped amino acid. Source C, does it have an ACE group? Yeah, I don't think. So the ACE group, these are just like neutral caps. It seems like. Maybe AlphaFold will recognize, or T-Leap. Let's check on this again, and it crashed. Unexpected JSON keys and user CC deep. So I think I just wrote the input script wrong. I'm gonna iterate on this forever, seems like. Here. What did I do wrong? What? Ugh. That's so annoying, man. So is this Python? Yeah, seems like it. Is this not Python? Should have sent it this too. It was a bashful learner, not valid Python syntax. That's cool. Escape.txt. Well, I hope that works. There we go. Let's move all these slurms. Alright. So we got that, all the files in there. So we just need to save, export molecule. Call it start. So, let's take a look at this. Simple jet. Yes, there's a lot of modifications. So 2KT, I don't know what that is. AlphaFold, I mean, Ember should support dehydrobutyrene. What? Like, why don't they just support those at this point? It's kind of BS. All right. Anyway, so we call ours CDB. I think they're in the same order as what threonine would be. I don't know what 2KT is. To me, it just seems like a cat. All right, so let me copy the from here. Um, all right. Then copy that to here. And then use this file path for this. And I don't think quotes are allowed. Then this will just be renamed to DHA. This would be LCH. All right, we need to change these now. Okay, this is running. Is it actually running though? I think it's running. Yeah. That's good. This MMCIF worked. So we would just need to modify that to get rid of the oxygen. Which I don't know, shouldn't be too bad. So it'll be this one. Thank God. Something's working. Will it get done in 10 minutes is the question now. So for this, so this is going to be annoying. All right, so let's do the threonines first. So we should probably look to here. Do the atom names correctly? Yeah. All right, so this is a cysteine and it's bonded to DAL. We don't care about that though. Care about this and that and this. Is this another DBU? No, this is just a regular threonine. No? Yeah, I guess so. So you probably just change that to threonine. Yeah, I think so. Shouldn't change much. But DBU2, so the N atom is N1. C3, Ca. I guess that's C6. C is C6. How do you change these names? Do we already change this one? Yeah. So O, there is no O. Or is it this? Why does it do that? Yeah, that's O. So it'd be O2. And then we got CB, so that would be C2. And then we got CG, that is C1. And then we can just get rid of all this stuff. All right, so that's how you change a DBU residue to ZDB. So this is done now. All right, moment of truth. Um, Something happened. So putting in a residue in between these two, see, didn't seem to work. Yeah. And not to mention there is no bond between the cysteine like there should be. So, um, oh, this one's something closer. Yeah, it's not going to break these bonds. So I think the deal is to create two separate sequences and have the C, like the C terminus of the leader be that, then the N terminus of the core, and then they're bonded together by the ligand. And then the cysteine is in between those two. So I think that's what we'll do. Um, all right, I'm gonna go eat some food because I'm starving. So I might be back in like an hour or so.